Hi students, welcome to Sunil's tutorial. I'm Sunil Medwani and today we'll be doing this chapter called as solid state. Let's see another sum, guys. Argon on crystallization at 179 Kelvin, argon or argon, whatever you call it, argon or argon on crystallization at 179 Kelvin forms an FCC lattice. With unit cell edge 5.4 Armstrong unit, with unit cell edge 5.4 Armstrong unit, with unit cell edge 5.4 Armstrong unit. Calculate Avogadro's constant. If the density and mass are 1.7 grams per centimeter cube and 40 grams. Right? Now, first of all, I can say volume is equal to AQ. Now, I can use the same formula that density is equal to mz upon NAV. Therefore, I can say that Na is mz upon rho v. I should be able to get the answer. I know m, I know z, I know rho. V can be substituted if you want as AQ. So, I know AQ also. Should be able to get the answer for this. Next, take our next one, please. At 270 Kelvin, copper metal crystallizes in face-centered cubic lattice. Copper metal crystallizes in face-centered cubic lattice with edge length of its unit cell 359.78 picometers. Find the mass of copper if density is 8.92 grams per centimeter cube. Find the mass of copper if density is 8.92 grams per centimeter cube. Right? I know A, so I can say V is equal to AQ. Same one formula, density is mz upon NAV. I want to find out density. So I could say that mz upon Na. Find the mass of copper. Density is given to you. You have to find the mass of copper. Mass can be written as rho Na. V can be written as AQ upon Z. Right? So I can find the mass of copper if its density is so much, right? This is going to be the mass of copper. That's your atomic mass of copper because I already multiplied the Avogadro's number here. Next, take on next one, please. Calculate the density of argentum metal. If it crystallizes in FCC structure, with edge length of the unit cell 405.75 picometers. Right? volume I can say is nothing but AQ, density is nothing but mz upon NaV, right? Now, argentum metal, I think I didn't give you this. Argentum metal, the atomic mass is not given to you. Now, the atomic mass you should know. Atomic mass is 108. Atomic mass of argentum metal is 108. This will be given to you in the sum. So mz upon NaV, you should be able to get the density. Right? So 108 upon, yes, you should get this. Atomic mass is 108. You know M, you know Z, you know Na. B can be substituted as AQ and you will get the answer for this. Next, take the next one please. Find atomic radius of a metal. Find atomic radius of a metal whose atomic mass is 197 grams per mole, whose atomic mass is 197 grams, just make that correction, 197 grams, and density is 19.03 grams per centimeter cube. The metal has an FCC structure, face centered cubic structure, right? Now let's see this. Let's first get the volume. I want to find out radius, right? We'll find the radius. First of all, let's get the volume. I can say density is nothing but mz upon Na into V. So I can therefore say V is nothing but rho mz upon Na into rho, right? So I'll come to know the volume. Once I come to know the volume, then I can say, but volume is nothing but AQ. So I can say that, but volume is nothing but AQ, right? Therefore A will be nothing but cube root of volume. How will I get the cube root of volume? I get this by log. Find the log of the volume, divide that by 3 and find the anti-log of that, right? That is the edge of the cube. Now for an FCC structure, the relationship between edge of the cube and the radius of the cube is A is root 8r. So I should be able to get the value of radius. The radius of the atom should be found, can be found out now. We can therefore say that r is A upon root 8. Root 8 is nothing but 2 root 2. Root 2 is 1.414. Substitute these values, you should be able to get the answer. Next. How many unit cells are present? How many unit cells are present in? How many unit cells are present in 2 grams of cubic crystal of NaCl? 2 grams of cubic crystal of NaCl, if the molar mass of NaCl is 58.5 and the cell content is 4. Right? How many unit cells are present in 2 gram cubic crystal of NaCl? Now, first of all, I have to find out first I can find out mass of 1 unit cell. mass of one unit cell, since it is a FCC structure, that means 4 into atomic mass upon Avogadro's number. 4 into atomic mass. Atomic mass is given to you as 58.5. Avogadro's number is 6.022 into 10 raised to 23. That will give me mass of 1 unit cells, right? So, number of unit cells in 2 grams will be nothing. 2 grams of NaCl will be nothing but 2 divided by mass of 1 unit cell. That 2 is nothing but, that is the mass of NaCl divided by mass of 1 unit cell. You found out the mass of 1 unit cell. Mass of NaCl is 2 grams. You should be able to divide and get the answer. In this sum, I could also find out the number of unit cells that are present along each edge of the crystal. Number of unit cells. This is not asked, I am finding this extra. Number of unit cells per edge. Number of unit cells per edge is given by the formula cube root of total number of unit cells. Right? Total number of unit cells you would have just found out from here. Number of unit cells in 2 grams, so you should be able to get this answer. Nice sum. Next, we go next one please. A face-centered cubic lattice. A face-centered cubic lattice of nickel has an edge length of 3.5 Armstrong unit. Has an edge length of 3.5 Armstrong unit. If the atomic mass is 58.7 and density is 8.94 grams per centimeter cube, find Avogadro's number. Right? This should be very simple. Rho is equal to mz upon Na into V. What does it ask you to find out? Na. Straightforward. Na is nothing but mz upon rho V. Right? Next. Sodium chloride crystallizes. Sodium chloride crystallizes in FCC lattice. Sodium chloride crystallizes in FCC lattice. Find the number of formula units of NaCl. Find the number of formula units of NaCl. Now, for FCC lattice, I can say that at 8 corners it will be 8 FCC is divided into 8 parts, 1 upon 8 if it is 8 corner. So you will get 1 chloride ion at 6 faces. There are 8 corners of the FCC lattice, 4 up, 4 down, right? At 6 faces, it will be 6 into 1 by 2. There will be 3 chloride ions, and at 12 edges, it is going to be nothing but 12 into 1 by 4. That is 3 sodium ions. Right? At the center of the cube, at the center of the cube there is going to be only 1 sodium ion. This is by geometry, hence total Count the number of chloride ions. 3 plus 1, 4 chloride ions. 3 and 1, 4 sodium ions. So there will be 4 sodium ions and 4 chloride ions. Hence the unit cell contains 4 units of NaCl. That's how we find out the total number of units of NaCl. Next, let's see another sum, guys. The edge of a unit cell of potassium chloride, is 6.2 into 10 raised to minus 8 centimeters, and its density is 1.98 grams per centimeter cube. Calculate the number of potassium ions. In 0.5 kgs of potassium chloride, if its unit cell has FCC lattice, and has 4 potassium and 4 chloride ions present per unit cell, Now, let's try to get as much information as possible. Edge of the cube is given, so I can find out volume. Volume is going to be nothing but A cube, right? Now, I can say that what have they asked you to find out? Calculate the number of potassium ions. First of all, let's find out weight of 1 unit cell. Weight of 1 unit cell. They said that density is 1.98 into molar into volume, right? So I can therefore get the weight of 1 unit cell, right? Weight as in you can see that the mass of 1 unit cell. Weight of mass interchangeably I am using. Mass of 1 unit cell I know, right? So mass of 1 unit cell is going to be so many grams, right? So I could say that number of unit cells in 500 grams is going to be nothing but mass upon mass of 1 unit cell. I know mass of 1 unit cell, I know I am using 500 grams, so I will come to know how many unit cells are going to be present in this. Now, since it is a FCC structure, the value of rank will be 4. Therefore, I can then say that the number of potassium ions, moreover they said that it contains 4 potassium and 4 chloride ions. Number of potassium ions in 500 grams of NaCl is going to be nothing but 4 into number of unit cells in 500 grams. Right? So you should be able to get the answer for this. Next, let's see another sum, guys. Potassium fluoride, which has sodium chloride type of crystal lattice. Potassium fluoride, which has sodium chloride type crystal lattice. Sodium chloride we know has a face center cubic crystal lattice, so its value of Z will be 4. So potassium fluoride, which has sodium chloride type crystal lattice, what is the distance between potassium and fluoride ions? What is the distance between potassium and fluoride ions if the density is 2.4 grams per centimeter cube? Right? Atomic mass of potassium is 39 and fluorine is 19. Right? So in that case, I can say that the molar mass of potassium chloride will be 39 plus 19, 49, 58. Right? First of all, I can use my formula that density is nothing but mz upon Na into V. So I could find out V as mz. I know m, I know z. Na, Avogadro's number. Density is given to me, so I'll come to know the volume. But volume is nothing but A cube. Therefore, I can say A is nothing but cube root of V. Once you get V, you find the cube root of V. Right? Now, distance between potassium and fluoride ions is going to be A by 2. I know the edge length, they are going to occupy half and half space. So whatever is the value of A divided by 2 will be the distance between potassium and fluoride ions. Fine, will we get this in here? Next, let's see another sum, guys. The ionic radii of cesium and chloride ions, the ionic radii of cesium and chloride ions is 1.6 Armstrong unit and 1.8 Armstrong unit. What will be the coordination number? What will be the coordination number of cesium ions? What will be the coordination number of cesium ions? Now, we know that the radius ratio is nothing but radius of positive ions upon radius of negative ions, radius of positive ions upon radius of negative ions. Solve this. Find the radius ratio. You will get this answer as 0.888, which is approximately equal to 1. Right? Now, the radius ratio between, I can say that the radius ratio is between 0.732 and 1. Therefore, its coordination number is going to be 8. If the radius ratio is between 0.73 and 1, then the coordination number of that will be 8. Fine. Next. That's a formula. Next, let's see this. What would be the structure of NaCl? What will be the structure of NaCl if the ionic radii of sodium and chloride ions is 0.945 Armstrong unit and 1.8 Armstrong unit. Now, I can first find out the radius ratio. Radius ratio is nothing but positive ion, radius of positive ion upon radius of negative ion. Right? When you solve this, you will get this answer to be 0.525, which is less than 0.732. Therefore, I can say that its coordination number is going to be 6. Right? And for 6, I can also give the geometry. Geometry is going to be octahedral. It will have a coordination number of 6 and it will have a geometry octahedral. Next, let's see another sum. What would be the coordination number of fluoride ions? What would be the coordination number of fluoride ions if the coordination number of barium ions, if the coordination number of barium ions in barium fluoride is 8. Now, from theory we know that a compound is always neutral. A compound is always neutral because coordination number and the charges of the contributing ions always balance, and the charges of contributing ions always balance, right? In which case, if they give you that the coordination number of barium ions is 8, that means if the compound is neutral, that means I can say that the coordination number of fluoride ions should also be 8. Only then will the compound balance, right? That coordination number of barium is 8 suggests that it is surrounded by 8 fluoride ions, right? Now, barium has a positive charge of +2. Suggests that it is surrounded. Coordination number of barium is 8 suggests that it is surrounded by 8 negatively charged fluoride ions, right? Now, in order to balance 8 negative fluoride ions, negative charges of fluoride, ions, 4 barium are required. Question: so why 4 bariums are required? Because fluorine carries unit negative charge, whereas barium carries a positive charge of +2. Now, if I have 8 fluoride ions, that means the charge will be -8 on fluorine. Barium has a charge of +2. Now, if there are 4 barium ions, 4 into 2, that means 8. Now, therefore, I can say that the coordination number of fluorine is going to be 4. To balance 8 negative charge, I require 4 barium ions. Therefore, the coordination number of fluorine is going to be 4. Next, let's see another sum, guys. Why does zinc sulfide sulfide, why does zinc sulfide, whose radius ratio is 0.402, whose radius ratio is 0.402, not crystallize in the NaCl type structure. Now, for anion contact, I want to make contact between the two anions in a crystal structure. The minimum radius ratio should be the minimum radius ratio should be 0.414. Only then you will have an anion contact, right? Whereas in zinc sulfide has radius ratio 0.402, which is less than 0.414, which is too low to avoid anion contact, which is too low to avoid anion contact, which is too low to avoid anion contact in NaCl, right? At the same time, the radius ratio is greater than 0.414, then the two chloride ions will not touch each other, right? So I can say that at the same time, if the radius ratio is greater than 0.414, then the two chloride ions will not touch each other. Then the two chloride ions will not touch each other. Fine, do we get the same here? Next, let's see another sum, guys. I can say that aluminium oxide crystallizes with aluminium ions, in 2/3 of the octahedral holes, in closest packed array of ions. What should be the formula of aluminium oxide? Now, I can say that there is one octahedral hole in per oxide ion. There is only one octahedral hole per oxide ion, and they are saying that 2/3 of these holes are occupied. That means I can say that the ratio is 2/3 is to 1, which is nothing but 2 is to 3, right? Hence, formula of aluminium oxide should be Al2O3. That's how you get the formula of aluminium oxide, by taking the ion ratio, right? Okay, we'll stop this here for the day. Thank you very much.